Okay, here we are in chapter 7. So chapter 7, we're going to start off here by looking at proportions and comparing things. So first thing we want to start off with is a definition here. So we've got this definition of a ratio. So a ratio is a comparison of two quantities by division. So we write it as A over B. Sometimes you could say A to B. We could also say A like colon B, which is just also, again, A to B. So as an example here, a bonsai tree is 18 inches wide and stands 2 feet tall. What's the ratio of the width to the height? All right, well, the problem here is we've got inches and then we've got feet. So the 2 feet, we've got to change it to 24 inches. So I would say, so the width to the height, so 18 over 24. And if I reduce that fraction, they're both divisible by 6, so I get 3/4. An extended ratio is a comparison of 3 or more numbers. So we can write it as A colon B colon C, which is like A to B to C. We don't really write it out like with the 2's when we have 3 of them like this. You can also write it like this. So this would also be an extended ratio. If you can see there, I've got the B's in the same place. All right, the lengths of the side of a triangle are in the extended ratio 4, 7, and 9. The perimeter is 60. What are the side lengths? So the sides could just be 4, 7, and 9, but the problem with just 4, 7, and 9, 4 plus 7 plus 9 is only going to give me 20, so that's not going to get me to the 60. So I have to figure out how I want to scale up these numbers. So like maybe if I scale them by 2, I'd have 8 plus 14 plus 19, but that's still not going to give me 60. But you probably figure out where I'm going. But anyways, instead of me guessing and checking here with my calculator, why don't I just try to set up a equation here? So I'm going to just say 4x plus 7x plus 9x. So I'm just using those ratios there, equal to 60, the perimeter. Because remember, the perimeter is just the distance all the way around the triangle. This ends up being 20x equals 60. Divide both sides by 20, x is equal to 3. So then my sides, because it asked me what are the side lengths, so 4 times 3 is 12, 7 times 3 is 21, 9 times 3 is 27. A proportion is an equation that states two ratios are equal. Then there's this idea here of extremes and means. Okay. This is one, like the means we're going to find in a later section here. If I write A over B is equal to C over D, the numbers that are in this spot are called the means. The numbers that are in this spot are called the extremes. Okay, so that's just all, it's just a little notation there. All right, cross product properties. So if you, maybe when I drew those circles there, you kind of remembered doing this before, but in a proportion, the product of the extremes equals the product of the means. So all that's saying is there is A over B equal to C over D. So if I cross multiply there, AD is equal to CB, sorry, BC. So A times D, so I'm just cross multiplying. A times D is equal to B times C. So I can use this idea to solve some problems. So here I want to solve for A, so I can cross multiply 2A, and then 9 times 14 is 126. Divide both sides by 2. A is equal to 63. Same thing over here. Cross multiply. I get 15m, and then over here I'd have 3 times m plus 1. So you have to remember to distribute that 3. So I have 15m is equal to 3m plus 3. Subtract 3m. 12m is equal to 3. So m, divide both sides by 12, I'd get 3/12, so m is equal to 1/4 if I reduce it. Okay, so then further on we have some properties here. We have 3 different properties. So a, b, c, and d do not equal 0. So what this is saying here is a over b is equal to c over d. If this is true, that's equivalent to b over a is equal to d over c. Just think about it. If I cross multiply here, I'd have a times d is equal to b times c. If I cross multiply over here, I have b times c is equal to a times d. So even though these numbers are flipped, in the end, when I cross multiply, I get the same thing. So as an example, if I have 2 over 3 is equal to 8 over 12, that's equivalent to saying 3 over 2 is equal to 12 over 8. So as you can see, I just flipped it. All right, here, if we have a over b is equal to c over d, that's equivalent to a over c is equal to b over d. So if you notice here, we'd use these ones over each other. But again, let's look. A times d equals b times c. A times d equals b times c. So I'm still getting the same thing when I cross multiply. So what this means is it's saying if I had 2 over 3 equal to 8 over 12, the equivalent expression, I could say that 2 over 8 is equal to 3 over 12. All right, this last one here, it says a over b is equal to c over d is equivalent to a plus b over b equals c plus d over d. Again, let's look here. I get a times d is equal to bc. If I cross multiply this way, I got AD plus BD is equal to, so again, when I multiply that, I got to distribute. I get BC plus BD. Well, if I subtract BD from both sides, I'm going to just end up with AD is equal to BC. So again, I've got the same thing that I started with over there. So this is like saying 2 over 3 is equal to 8 over 12 is the equivalent expression as 2 plus 3 over 3 equals 8 plus 12 over 12, okay? So for these two pieces here, so we're starting off with this proportion. So x over 6 is equal to y over 7. And it says, what ratio completes the equivalent proportion? Justify your answer. So here, you notice here that they flipped it. So I'm going to say this is 7 over y. And the first property is the one that flips. So I'm going to say properties of proportions, number 1. All right, then we have the one here that's adding. That's this third one right here. So here I must have x plus 6 over 6. So this is properties of proportions, number 3. All right, on the test, if I ask you to write anything out, you're not going to have to remember the numbers. You could just say properties of proportions, but just realize that you want to just remember what those different properties are. All right, what I'm going to do now is I'm going to take the homework problems and maybe do a couple here with you. So I'm going to open up my book. And let's see here. All right, I'll do 37. And I'm going to do 46. And I'm going to do 58. All right, so 37. Thirty-seven says that the area of the triangle is 150 inches squared. The ratio of the, the area of a rectangle is 150 inches squared. The ratio of the length to the width is 3 to 2. Find the length and width. So if you remember here, the formula for the area of a rectangle is just base times height. And so what we just know here is that the ratio of the length to width, again, instead of using base times height, maybe I'll use length and width, same thing. But we know that the ratio of the length to the width is 3 to 2. But I don't want to use 3 and 2 because 3 times 2 is only going to give me 6. So I got to say 3x and 2x, okay? So the area is 150 inches squared. The length, 3x. The width, 2x. So I have 150. I have 6x squared. Divide both sides by 6. X squared is equal to 25. To get rid of the square, I'm going to take the square root. So x is equal to 5. It could also be negative 5, but that doesn't make any sense when I'm talking about a rectangle. So then my length would be 3 times 5, or 15. My width would be 2 times 5, or 10. Okay? All right, let's see here. I said I was going to do 46. So 46. It says the means of the proportion are 4 and 15. List all possible pairs of positive integers that could be the extremes. So again, what I just said to you, the means were in the position, these positions right here. So if the means are 4 and 15, the extremes are here and here. So when I cross multiply, a times b, 4 times 15 is equal to 60. So what numbers here, what pairs of numbers could I multiply to get 60? So I could have 1 and 60. I could have 2 and 30. I could have 3 and 20. I could have 4 and 15. I could have 5 and 12. I could have 6 and 10. And that's it. Okay, so those are the different options that I could have for those extremes, those A's and B's there. All right, and then I said we were going to do 58. All right, this one is the fun one because it has a quadratic equation in here. All right. All right, so this is where you guys sometimes forget things. So when I cross multiply here, I'm going to cross multiply the x's first. It doesn't really matter. I just like to have my x's on the left. And then 3 times 2 is 6. All right, don't forget when you see something like this, you need to FOIL. All right, so I have to do the first, the outer, the inner, and the last. I would combine like terms. And then I could subtract 6. So at this point right here, you could use the quadratic formula, if you remember that, or you can also think about, okay, let me go backwards now. I'm like unfoiling it. So what numbers would I multiply to get negative 12, but when I add them together, I get negative 1? So like 6 and 2, let's say negative 6 and 2, I can multiply those together to get negative 12, but if I add them together, I am not going to get negative 1. So 4 and 3, if I want negative 1, I got to make this one bigger. So negative 4 times 3 would give me negative 12. Negative 4 plus 3 would give me negative 1. Okay, so this one works. So then up here I have x minus 4, x plus 3. Again, if you FOILed this again, x times x, x squared, I'd have the negative x in the middle, and I'd have minus 12. All right, so then I know that the quantities, so the quantity x minus 4 times x plus 3 have to equal 0. So that means one of these has to be equal to 0. So it's either x minus 4 is equal to 0 or x plus 3 is equal to 0. Here, I'd get 4. here, I get -3. So that's where the answers come from. Okay? All right, so that was 3 of those homework problems, and that's all I'm going to do with you right now.